One important idea in a research project is the unit of analysis. The unit of analysis is the major entity that you are analyzing in your study. Several units of analysis include individuals, groups, organizations, and social artifacts. Individual human beings are perhaps the most commonly used units of analysis in social science research. Some examples are college students, single parents, Catholic churchgoers, factory workers, and gang members. Another unit of analysis is the social group. A researcher may be interested in characteristics that belong to one group, considered as a single entity. If the researcher was studying all gangs in a city to learn the differences between them, big gangs versus small gangs, West Side gangs versus East Side gangs, the unit of analysis is the social gang as a group because the researcher is interested in gangs rather than their individual members. Another unit of analysis is the social artifact. Now, let me show you a video clip related to sampling. Hope it can help you understand sampling issues. Here is a picture for you to understand what the population and the sample mean in an empirical study. A variable is any characteristics, number, or quantity that can be measured or counted, having the value which vary between data units in a population and may change in value over time. Here are different ways variables can be described according to the ways they can be studied, measured, and presented. First, categorical variables have values that describe a quality or characteristic of a data unit, like what type or which category. Categorical variables fall into mutually exclusive in one category or in another, and exhaustive include all possible options, categories. Therefore, categorical variables are qualitative variables and tend to be represented by a non-numeric value. As a categorical variable, an ordinal variable takes a value that can be logically ordered or ranked, while a nominal variable has a value that is not able to be organized in a logical sequence. Scale variables have values that describe a measurable quantity as a number, like how many or how much. Therefore, scale variables are quantitative variables. As a scale variable, an interval scale measures where the distance between any two intervals is the same but the 0 point is arbitrary. On the other hand, variables at a ratio scale vary quantitatively in a fixed and dependable manner and have a real zero. This figure categorizes those four types of variables. Using numerical and graphical ways, we can describe and display empirical data. Descriptive statistics is the term given to the analysis of data that helps describe, show or summarize data in a meaningful way such that, for example, patterns might emerge from the data. Descriptive statistics do not, however, allow us to make conclusions beyond the data we have analyzed or reach conclusions regarding any hypotheses we might have made. They are simply a way to describe our data. A statistical graph is a tool that helps you learn about the shape or distribution of a sample. The graph can be a more effective way of presenting data than a mass of numbers because we can see where data clusters and where there are only a few data values. One simple graph, the stem and leaf graph or stem plot, is a good choice when the datasets are small. To create the plot, divide each observation of data into a stem and a leaf. The leaf consists of one digit. For example, 23 has stem 2 and leaf 3. 432 has stem 43 and leaf 2. 5432 has stem 543 and leaf 2. A histogram consists of contiguous boxes. It has both a horizontal axis and a vertical axis. The horizontal axis is labeled with what the data represents, for instance, distance from your home to school. The vertical axis is labeled either frequency or relative frequency. The graph will have the same shape with either label. Frequency is commonly used when the dataset is small and relative frequency is used when the dataset is large or when we want to compare several distributions. The histogram, like the stem plot, can give you the shape of the data, the center, and the spread of the data. The histogram is only appropriate for variables whose values are numerical and measured on an interval scale. The other statistical term to describe the data is percentage. It is a number or ratio expressed as a fraction of 100. Likewise, percentiles are values that divide a sample of data into 100 groups containing, as far as possible, equal numbers of observations. Percentages are really no different from any other form of statistics. They gain their meaning only through their context. Percentages should be presented in context. When writing your statistical results, please set the context first. Then, give the evidence and state the conclusion. A summary measure describing a whole set of data with a single value that represents the middle or center of its distribution. Mean, sum of all values / total number of values. Median, middle value when the data are arranged in order. Mode, most common value. 6. Central tendency. One of general types of statistic used to describe data is measures of central tendency. It is a summary measure describing a whole set of data with a single value that represents the middle or center of its distribution. We can describe this central position using a number of statistics, including the mode, median, and mean. The mean, or average, is the most popular and well-known measure of central tendency. The mean is equal to the sum of all the values in the dataset divided by the number of values in the dataset. The median is the middle score for a set of data that has been arranged in order of magnitude. The median is less affected by outliers and skewed data. The mode is the most frequent score in our dataset. On a histogram, it represents the highest bar in a bar chart or histogram. You can, therefore, sometimes consider the mode as being the most popular option.